Okay, this question is question 8, and it says a company wishes to make two types of garden bench, the rustic and the contemporary. The company wishes to maximize its profit, so we're going to maximize profit, and decides to use linear programming. Let X be the number of rustic benches made in a week, and let Y be the number of contemporary benches. The graph in figure 6 is being used to solve this linear programming problem. Two of the constraints have been drawn, so namely this constraint, this is a constraint here, and this is a constraint here. Write down the constraints shown on the graph, giving your answers as inequalities. So, for part A, look, part A is easy. All we've got to do is identify the equations of these lines. Now this line here is clearly the line Y, well you think is 15, but a lot of students made that mistake. It isn't, it's 1 up from 15, it's actually 16. Be super careful, that's the line Y is equal to 16. Now, what's the equation of this line here? Okay, so the equation of that line there, well, we know it's got a y-intercept of 0, and we can work out the gradient really easy. The gradient, as you go across 10, you go up 20, so the gradient must be 2, right? We could formally work out the gradient, like say if I worked out the gradient here, I could say the gradient is the difference in y's, so let's pick something that definitely goes through there. So let's say it's 20 take away 0, 20 take away 0, divided by the difference in x's, 10 take away 0, which is clearly 2. Okay, so I could have worked out the gradient like that. Okay, so what I'm going to do, if that is the line, therefore using y equals mx plus c, y equals mx plus c, and you know c is 0 because it crosses at 0, this line here must be y is equal to 2x. And this line here we said is y is equal to 16. Now, we want below the line, okay, so therefore one of the inequalities must be y less than or equal to 16 because it's not a dotted line. So y must be less than or equal to 16 is one of the constraints. We also want underneath the line here, so we want y less than or equal to 2x. So y less than or equal to 2x. So there are two constraints. Part B, it says it takes 4 working hours to make a rustic bench. So I'm going to highlight that yellow. I've highlighted everything yellow for the rustic. So 4 hours to make a rustic one. So 4 hours to make a rustic. And it takes 3 hours to make a contemporary one. And there are 120 hours available in the week. So let's write this down as an inequality. Well, for part B, if I make x rustics and each one takes 4 hours, 4x is the number of hours for rustic benches. And if I make y contemporary and each one takes 3 hours, 3y must be the number of hours needed for those. If I add them together, I know it must be less than or equal to 120 because that's the available hours. So what I'm going to write 4x add 3y must be less than or equal to 120. And that's my next constraint for 2 marks. Then it says the following. It says market research shows rustic benches should be at most 3/4 of the total benches. So let's write that down step by step for part C. Now rustic benches, the rustic ones, remember we've highlighted these up here, the rustic are x. So the number of rustic benches, it says, should be at most, so that's less than or equal to 3/4 of the total. So 3/4, now the total number of benches is the number of rustics, add the number of contemporaries, so x plus y. Now they've asked us to simplify this inequality. And your inequality must have integer coefficients, which ours currently doesn't. So multiply everything by 4, so that we'd have 4x is less than or equal to 3x add y. Multiply out the brackets, 4x less than or equal to 3x add 3y. And collect everything, let's say on one side. Let's subtract 3x from both sides, so x bigger, less than or equal to 3y. And I like writing this the other way with y first, so 3y bigger than or equal to x, okay? Or like that. So that's absolutely fine if I leave it like that. Okay, what's next? Add the two lines in diagram 1 and hence determine the feasible region. So what we've got to do, these two have already been added. We've got to make sure we add this one and make sure we add this one here. Okay, so what we're going to do, let's add this one first. So I'm going to go over here and call this part D. Let's draw the line 4x add 3y is equal to 120 first of all. Now if x was equal to 0, 3y would be 120, so y would be 40. So 0, 40 passes through, the line passes through 0, 40. On the other hand, if y was 0, 4x would be 120, so x would be 30. So 30, 0 passes through. So let's plot those points 0, 40 and 30, 0. So 30, 0 is here, 0 across, 40 up is here. We're going to draw a straight line, not dotted, because it's not a strict inequality. And we want 4x add 3y. We want this line less than 120. So we're looking for underneath here. So we're going to shade everything that's over. So this is already shaded, but we're also going to shade this stuff here. And the last one, we want to draw this one here. Okay, we want to draw that one there. I find it easy to do some working over here and say, let's draw y bigger than or equal to a third x, dividing both sides by 3. And if I know it goes through 0, 0, x is 0, y is 0, it certainly goes through that. Pick an x that divides by 3. Let's say if x was 90, y would be 30. So that's how it goes through that. So let's plot 0, 0, and let's say x is 90. Well, x is 90 is too big, so let's just pick instead x is 30. If x was 30, y would be a third of 30, which is 10. So it goes through 30, 10. So 30, 10 would be here. And we're going to draw our line like that. Okay, I'm going to draw our line there. And we want y bigger than this, so we want above the line. So we're going to shade below the line here what we don't want. And so our feasible region R is as follows on the diagram. Okay? Right, now I always label this point the origin. This is the origin. I'm going to label this point A, I'm going to label this point B, and I'm going to label this point C, just in case we need to reference them in the future. Then it says, the profit on a rustic bench, now remember the rustics were the yellows, the profit on the rustic bench is £45, and the profit on the contemporary bench is £30. We want to write the objective function P. So for part D, it's easy. The profit P is clearly going to be 45 multiplied by x, add 30 multiplied by y. So 45 multiplied by x, add 30 multiplied by y, as follows. Okay, so that's our profit function, or what's called our objective line. And then it says, determine the coordinates of the vertices of the feasible region and hence use the vertex method. You must use the vertex method to determine the optimal point, i.e. the maximum P. So what's best to do in these cases, I always find, is best to draw a table. So what we're going to do is, I'm going to call this part A, we're going to draw a table. So we're going to say coordinate, we're going to say point. So we're going to say the point, the equations, the solution, and the value of P, which is 45x plus 30y. So the first point is the origin. The next point I said was A, B, and C. So we've got A, B, and C. Now at the origin, we know the solution, it's 0, 0 there, and the profit would therefore be 0. That's an easy one. Now, what about point A? What equations meet what? Well, y is 16 meets y is 2x. So I'm going to write here the equations are y is 16 and y is equal to 2x. So if I solve these, 2x is 16, so x must be 8. So x is 8 as a solution and y is 16 as a solution. And if I substitute in here 45 multiplied by 8, add 30 multiplied by 16, I get my profit. So I can get my calculator out and I can just say simply 45 multiplied by 8, add 30 multiplied by 16, and my profit's 840 there for that one. Okay, so for B, what two equations are meeting? Well, y is 16 is meeting this one here. Now that one was this equation here, 4x add 3y is equal to 120. So y is 16 is meeting 4x add 3y is equal to 120. So we need to solve these simultaneously. If I stick y 16 in here, I would get 48, and 4x would therefore be 120 take away 48. So I could do 4x would be 120 take away 48, and that's 4x. If I divide it by 4, I get x is 18. So I clearly know that 16 is another solution. So the profit here would be 45 multiplied by 18 add 30 multiplied by 16. So the profit in this case is going to be bigger. It's 45 multiplied by 18 add 30 multiplied by 16. And I get myself £1,344. Sorry, that was 45, my mistake. Sorry, I've made a mistake there, sorry. That was, should go back here. That wasn't 48 at all, that was 45. And there we go, 1290 instead. So that was 1290 there. So I'll rewrite that. The profit was 45 multiplied by 18, add 30 multiplied by 16, which was equal to 1320. And the last one, point C, what meets at C? Well, the 4x add 3y meets this one here, which is 3y is equal to x, or y is equal to a third x. So for the last one, 4x add 3y is equal to 120. Meets, I can write this equation, 3y is equal to x. So solving these, I could substitute in x in there for the 3y. So this would be 5x is 120. So if 5x is 120, 1x must be 120 divided by 5 is 24. So x would be 24, and y would be a third of 24, which would be 8. So there's our other solution. So it'd be 45 multiplied by 24, add 30 multiplied by 8. And we can say 45 multiplied by 24, add 30 multiplied by 8, and we get 1320. So 1320 for this one here. Just thinking here, I think I've made a mistake on this one. 45 multiplied by 18, add 30 multiplied by 16 is 1290. This should have been 1290. I don't know why I wrote that. This one should have been 1290. I realised that when two of the answers were the same. 1290, like that. Now, we want to maximise profit, so the maximum profit clearly happens at C. So going up here, we use the vertex method to find the optimal point. So we just state that the optimal point is C, where x is equal to 24 and y is equal to 8. And for the last point, point E, it says state the profit. Well, the profit is, we said 45 multiplied by 24, add 30 multiplied by 8, which is equal to 1,320. And that's our answer for this question. And we're done for the whole 16 marks.